Hello and welcome to COP4708, Lecture 1 of Module 3, the Relational Model. This is just getting us started here. Let's kind of delve right into it. This one's relatively simple. First, why do we use the relational model? Well, reality is it's one of the easiest and most flexible models for modeling data that we've got. And it really is simple. It's records that are organized into groups and grouped into relationships. First, there's going to be a lot of terms that we're going to talk about. Entities, relationships, functional dependencies, all these. Okay, so the list, you're going to see them all over the course of the next, well, a lot of them this week, but over the course of the next couple of weeks. So don't worry about it right now. They're all going to make sense in the end, and that's really important. But right now, we're really just going to talk about entities and relationships in this first lecture. So, what is an entity? Well, it's a thing, okay? It can be a physical thing, like a computer. It can be a more of something that's happened, like a transaction, sales. But essentially, it's something that you can identify and that you need to keep data on. And that's the whole reason why you're doing this for databases in the first place. So let's move forward. And we're looking at terminology here. You're learning to speak the language of databases. So first, attribute. What is an attribute? Well, we also call them interchangeably all the time. You're going to hear the terms attribute, field, or column. So let's take an example. The concept of a student being an entity. The student can be identified by a number of attributes. They can be identified by their name, their student ID, their street address, their email address. Now, not any single one of these attributes is going to be unique to that individual student. Other students could have the student's name. Other students could have the student's address. They could live at the same location. But the ID and the email would actually likely be unique attributes to that student. We're going to talk about a little bit about that later as we work our way along, but the concept is pretty straightforward. A property that's descriptive of the entity. Okay? In this case, example, simple, the student, you, a person, entity, and these being specific attributes. In the database world, we'll often call them columns and sometimes call them fields. I like to use the term column because it kind of gives you a good representation of the table nature of these types of databases. All right, so next. What's next here? Well, tuples. What's a tuple? Well, tuple is a fancy name for a row or a record or an instance, okay? And in the case of databases, it's a row in the database. All the things along that row at least have some sort of relationship to the actual entity that's being described. Now, city, in this case, Daytona Beach, okay, would probably not be a great description of the tuple as an attribute, but it is an attribute because it is something that actually is associated with the row, the student themselves. Just not the best because obviously there's more people that can live in that city. But name, again, same thing. Name, well, it's descriptive, but not 100% descriptive. Student ID, best description, it's unique. So relations or relationships, we like to store information about the entity itself in these rows, and data is stored this way in tables, relation tables. So when we say that we have an entity, the entity might have an ID, a number that's associated with them, a name, okay, a department. These are descriptive pieces of information about that specific entity. They have a relation to that entity. Okay, they may also have a relation to other entities like the department. There's going to be more than one person possibly in accounting or finance, as you can see in the thing, but that have a relation to the entity that you're describing, because that entity that you're actually in that row, in that tuple, is a member of that department. Okay, again, don't overthink this. It's not that terribly complex. Now, we're going to make it so that there are ways of dealing with the entire concept of being, multiple people in the same department and all that, which we're going to talk about as we move forward. Don't need to worry about right now. Now, so two-dimensional table that has following characteristics, and these characteristics are pretty much, again, you can look at this and go, oh yeah, there's a lot of characteristics. No, it really isn't that complex. The rows contain data about an entity. Okay, that is information about that specific entity, and the columns are the attributes. Okay, each column describes an attribute, and the data about that specific entity in that specific column are that type of data for the entity. Okay, in other words, a cell has a meaning that pertains to the row of whatever the entity is describing. Entries in each column are of the same thing or the same kind of thing. Like when you say phone number, it's just the phone number. Columns have unique names. They have to have unique names in entity relationship databases. Okay, that's kind of important because you need to be able to describe specifically what is in that, what that cell means, that entire column means. Okay, we don't care about the order of the columns. We don't care about the orders of the rows. Okay, now, when you're doing database programming in a third-party language, a language where you're trying to access the data, sometimes you do reference the columns by the column number. So in that specific situation, changing the order of the columns will have an effect on something later on down the line. The best way to deal with that in practice, don't use the column order in your programming. Okay, use the column name in your programming, and that won't cause a problem. And then in a relational database, no two rows are the same, identical. Okay, now there's ways of dealing with this also. And again, everything in here has an enforcement mechanism that needs to be done. So as you're building entity relational databases, the enforcement mechanisms help you maintain this concept of the relation. Okay, seems like a lot. Reality, it should all make sense. It should make sense that columns have to have unique names. It should make sense that the rows are unique. It should make sense that you really don't care about column order and row order. Okay, it's just pieces of data. Okay, those things should make sense. Now, you have the ability to have values of things in there, like a comment that you can put into a relational table. Okay, that doesn't violate anything about those specific rules. However, something like putting in multiple phone numbers can be a violation of the rules of the table. Okay, now what you're doing here when you're building a table like this is you're saying, okay, this phone has one phone number, this phone down here has multiple phone numbers, and then two of those phone numbers in the first example aren't even unique. Okay, there's a better way to do that. They're not good relation tables. Now, can you build tables that do this? Oh yes, definitely you can. You can set the phone number up to be a string and make it be what, just like that column. Okay, but not a good practice. Okay, violates the concept of a solid relation. Is there a better way to design it? Sure. Have something like the first number being department number, second phone number being personal number, the third column being fax number. There's ways to deal with that. Okay, even identifying. Now this one's really bad because in the email column or the email field, we've gone ahead and thrown in fax and home, but now look, the table, the employee number, okay, this just is a mess. Not a good table. Sure, it's perfectly humanly readable. You can look at this and you can see, oh yeah, I can tell exactly what these different things are. Okay, a machine needs to have the logic to read this kind of stuff built in. Oh yeah, by the way, if the email column has the name fax colon in it, then the following field, okay, the following cell in the phone field is actually a fact. No, that's a mess. Don't do it. Okay. You're going to learn how to do these the right way. And really for this lecture, because we're going to try to split this up into multiple pieces, that's about as far as we're going to go. So you're going to use the term table, really. We can use table and relation, interchangeably. But you know what? It's a lot easier just to think of them in terms of tables and understand table is a very generic term. There's lots of kinds of tables. I'm actually got my computer sitting on top of a table. Ha ha ha. Anyway, but it's not a relation. Not related to the table. Okay, so some of the different names that we have for things are interchangeable, but really I'm going to use the concept of I'm going to say tables instead of relations. I'm going to say columns instead of attributes. I'm going to say rows instead of tuples, but you need to know that if somebody says relation, attribute, or tuple, that we actually mean the same thing when we're talking about it, even though I'm using a more generic term than those terms. All right, this should be pretty straightforward. If you have questions associated with specific items in this lecture, of course, you can always throw those suckers up to the discussion board. Really, more likely you're going to have questions about things that are in your homework assignments, and I'm really expecting questions on those. So hopefully you have enjoyed this, and we're going to get onto that next lecture where it's going to get a little bit more complicated.